Hello, I'm Ömer. This project focuses on the wind energy within the scope of the renewable energy course. First, renewable energy will be discussed and then the focus will be on wind energy. Renewable energy, also known as clean energy, plays a crucial role in addressing the global challenge of climate change, energy security, and sustainable development. The importance and advantages of renewable energy shows in the figure. First, environmental benefits. Renewable energy sources such as solar, wind, hydro, and geothermal power generate electricity without emitting greenhouse gases or pollutants that contribute to air pollution and climate change. Climate change mitigation. Renewable energy is a vital tool in combating climate change. By replacing fossil fuels with clean energy sources, we can significantly reduce carbon dioxide and other greenhouse gases emissions. Energy security. Unlike finite fossil fuel reserves, renewable energy sources are abundant and widely available. Economic growth and job creation. The renewable energy sector is a significant driver of economic growth and job creation. Investments in renewable energy technologies spur innovation, manufacturing, and infrastructure development, creating new employment opportunities. Energy access and affordability. Renewable energy offers the potential to bring affordable and clean electricity to remote areas that lack access to traditional power grids. Off-grid renewable energy systems such as solar home systems and microgrids provide energy solutions for communities in developing regions, improving living standards and supporting economic development. Health benefits. The transition to renewable energy source leads to improved air quality and reduced pollution-related health issues. Technological advancements. The pursuit of renewable energy has driven technological advancements and innovation in energy storage, great integration and efficiency. Overall, the importance and advantages of renewable energy is able to mitigate climate change, promote sustainable development, enhance energy security, foster economic growth, improve public health, and drive technological innovation. Trans- transi- Transitioning and to a clean energy future is a critical step towards a more sustainable and resilient planet.
Importance of wind energy. The significance of wind energy gaining momentum is thanks to German aircraft engineer Ulrich Hütter, this guy. Prior to that, Paul Lacour's first 5 and 4-bladed wind turbine models were also important milestones. By the 1960s, different models began to emerge, but these models were based on Paul Lacour's fundamental idea, this guy. According to Lacour, wind turbines with fewer and slender blades were a more powerful alternative in terms of efficiency. Following this idea, Lacour reduced the number of blades to 2, but today we frequently see 3-bladed turbines, especially in large open area. There is a simple reason for this 3-bladed design: distribute the weight evenly and reduce torque, maximizing energy efficiency. As a result, the use of wind power plants (WPP) worldwide may experience some years of decline, but it will steadily increase in the coming years. Figure shows the total megawatt capacity of the top 10 countries in the world with the highest WPP utilization in 2021. Use of wind energy in Turkey. Wind energy production has shown a steady increase in not only globally but also in Turkey. As seen a figure, according to the International Renewable Energy Agency, the amount of the wind energy production in Turkey has been steadily increasing every year. The place of the wind energy in the world. The energy demand in the world is increasing every day due to advanced technology. Based on the data in figure, we can interpret the position of the wind energy among renewable sources in various ways. But we can clearly state that wind energy maintains and even increases its importance among other renewable energy sources.
I will talk about site selection and types of locations for wind energy projects. Site selection for wind energy involves several considerations to ensure optimal performance and efficiency. Here are some factors that are typically taken into account when choosing locations for wind energy projects. Wind resource assessment. A thorough assessment of the wind resource is essential. Wind speed, direction, and consistency data are collected using meteorological towers or remote sensing technologies like LiDAR. A site with a consistent and strong wind resource is preferred for higher energy production. Here are some regions where wind speeds are high. North Atlantic Ocean have a rich potential. Countries such as Scotland, Ireland, England, and Denmark. The Sahara Desert and coastal regions of the Indian Ocean, also Brazil. Great Plains of the United States. The Great Plains in the United States are known as favorable areas for wind energy projects. States such as Texas, Kansas, Iowa, and Oklahoma have large wind farms. Wind turbine siting. The site should have sufficient space and appropriate wind conditions to accommodate wind turbines. Factors like land availability, topography, and proximity to transmission lines are considered. Open areas with minimal obstructions, such as tall buildings or trees, allow for smoother wind flow and better turbine performance. Distance from population centers. Wind energy projects are generally located away from densely populated areas to minimize potential noise and visual impacts on communities. It's important to note that site selection is a complex process that involves multidisciplinary expertise, including meteorology, engineering, environmental science, and stakeholder engagement. Ultimately, the preferred locations for wind energy projects are areas with strong and consistent wind resources, suitable land availability, minimal environmental impacts, accessible infrastructure, and compliance with regulatory requirements.
Hello, it's Mithat. My friends mentioned about renewable energy and also focused on wind energy. Here, it's the main part of the project. I will tell about the wind energy calculation. The two type of calculation is taken into consideration in our project. One of them is variable distribution method. The other one is turbine energy calculation. So I will explain steps of variable distribution methods. One of the steps is wind speed data. The wind speed data include the velocity of wind, the location that has been setting up the wind energy plant. After that, variable parameter estimation is needed. The K and C parameter has to be calculated for variable distribution. After variable parameter, variable distribution is obtained. According to this, power and energy can be calculated. Our selected location is Istanbul Sarıyer, and its wind data has been received from Global Wind Atlas. So this is the variable distribution function. It includes K, C, and V. V is velocity, and K and C is the parameter of the variable distribution that has to be estimated. There are several methods for estimation. There are some software to calculate it. One of them is EasyFit. Also, Python can be used. The energy density can be shown in the figure. Energy density includes air density and V and the other parameter. Here is our Python code to calculate our location wind energy, our calculation wind energy, and here is some function. One of them is variable function. It is already existed in the Python, and we calculate the power 1/2 times air density. It's 1.225 times velocity to the 3 times probability. It comes from variable distribution, and wind energy plus equal power times 8760. 8760 is the total hour in 1 year. After that, total wind energy is calculated. The total wind energy 15,594,544 kilowatt hour over meter square.
Hi everyone, I'm Metehan Aydın. I want to start with the location we'll select first. We have chosen an effective area for wind in Sarıyer. Enercon 53-800 kW wind turbine is selected. Enercon 53-800 kW is a specific wind turbine model manufactured by Enercon, a German wind turbine company. It has a power output 800 kW. We used this equation. Rated power is 800 kW. We took 12 meter over second rated power here. Cutting speed is 5 meter over second. It is minimum operating speed of the turbine. Cutout speed 25 meter over second. It is axis 25 meter over square second. The turbine's speed can cause damage, so the turbine is shut down. Swept area 2,198 meters square. The power coefficient equal 0.42. The power coefficient is taken from the intersection point of the table here. According to our own data, the graph next to it was plotted. Y-axis power output, x-axis wind speed. Python code we used to find the corresponding energy amount in our own data set. This is Python code. We calculate the annual energy by taking the average value of on data set. This is calculate the annual energy. Conclusion. First, we provided general information about renewable energy. Then we described wind energy, which we will focus on for our study. Finally, we conducted two separate calculations to reach the energy outcome. This is our references. Thanks for listening.